We'll now begin our study of composition of functions. Composing two functions is again done by replacing the independent variable of a function with another function. This is denoted by f composed of g of x. This is defined to be f evaluated at g of x. G is the input function. Sorry, there should be an f here. And x is the input of g. Something to note that we saw in the previous section is that the composition of functions f composed of g of x is not going to be equal to f of x times g of x. Let's try composing a few different functions. Find f composed of g, and also find g composed of f, where we're going to let f of x is equal to x squared plus 1, and g of x is equal to the square root of x plus 2. Let's number our problems. F composed of g will be 1, and g composed of f will be part 2. In part 1, we're looking at f composed of g. This is going to be equal to g of x squared plus 1. Replacing g of x with our function, this becomes the square root of x plus 2 squared plus 1. This is equal to x plus 2 plus 1. Now in part 2, we're looking at g composed with f of x. This is going to be the square root of f of x plus 2. Replacing our f of x, this becomes the square root of x squared plus 1 plus 2. We get that this is the square root of x squared plus 3. Note that g of f in this case is not equal to f of g. In general, this holds. Usually, functions composed in different ways give you different functions.